So I did want to actually showcase the visualizer real quick because that's probably something you want to see. So if we see real quick, every time that I hit the house, the visualizer goes red because colliding's true, and I'm calling show B-sphere. However, I am calling it in the draw function, but if we move this pretty much anywhere, um, I can call it right here. I can call it in the update actually. That's a better place for it because then I can have the collision test and show you that it's green and then it's red. So, but the update, obviously not part of the draw cycle, still drawing it. That showcases the render all function of the visualizer and that it's actually working. Yeah. Boom, we lost a life. Yeah, so I wanted to showcase that really quick, just so you didn't, or you would know that I'm actually doing that, or that it actually is working, and I'm not just spoofing it. Okay, so now let's stick with the form of left and right here with the .h is for the alarmables. So this is the alarmable. This is what you include in your game object class. As we can see, it's very similar to the drawables, the inputables, the updatables, with the registration state. The only difference is that this actually has a struct that contains all of this, with the registration state, registration command, deregistration command, and the time of the alarm. Now, it contains the registration data, which is the struct, an alarmable, obviously default constructor, submit alarm registration, submit alarm deregistration. These are called by user. Cancel alarm, add time to alarm, subtract time from alarm, and we can get the amount of time left on alarm. Just in case somebody wanted to check. So, yeah, and then these are the methods used this is used by the user. The user defines this method, and this is called by alarm manager. So in alarmable.cpp, we see the constructor. I create the registration, deregistration commands. As you can see, only one each. And then when we submit the alarm data, I assert to make sure that it's actually testing. Get the actual time that it really should be with the time manager, time in seconds. Then I submit the command for the registration of an alarm, and then I say pending registration. Much simpler for the deregistration. As we can see, I still do the test, submit the command, pin the registration, and now for cancel alarm, I just submit deregistration, because before the alarm goes off, those will be processed the way that I set up the scene.h. So those will be processed so it'll cleanly remove the alarm from the list. I felt like I didn't need to be more abrupt than that, simply because the way that the order of commands is relayed in the scene.h doesn't require a more abrupt touch than that. Plus, this gets the assert in there too, just as an extra security check, you know. So add time to alarm. We add time, or we assert that it's registered. We go to the current scene. We add time to alarm. We'll go to the definition for this, and that calls into the alarm manager. And it erases the current alarm and adds a new alarm for whatever time they want it to be at. Yeah. subtract time from alarm, subtracts the time. And as we can see, we don't need to do another calculation for the game time, simply because I do plus equals and minus equals. So there doesn't need to be a whole new calculation of time. It'll just add and subtract from the current time that the alarm is on. And then this will do the exact same thing in the alarm manager timeline.erase. It erases the current or the alarm, and then it inserts the new alarm. Yeah. So that's the alarmable. So let's go to alarm manager. Alarm manager, as we can see, we got a multi-map here that is ordered now because we want the lowest float to be first, and it's the timeline. The default constructor just creates a timeline. Storage entry ref. That's the delete ref in the alarmables. Deregister is the object. Process all the alarms, called in scene.h. Register the alarm. Add time to alarm. Subtract from alarm. So we've seen a few of these already through the peaking, but we'll just look here. So if it's gotten all the way here, it is deregistering, and it calls it, it erases it from the alarm list and deregisters, or it sets the registration state for the alarm as deregistered. Auto, obviously, just getting the beginning of the timeline here. Sorry. And then we only do one check. What we do here is just get the beginning of the timeline. We check to make sure it's not the end of the timeline, so if there are alarms on stack. And then if the first alarm is not triggered, then no other alarms are going to be triggered because that's the smallest alarm. And if it is triggered, then I deregister it, and I call trigger alarm on it, I deregister it, and I erase it. Registration, pretty much the exact same thing as deregistration. Erase, that's in the add time to alarm and subtract time to alarm, right there. We've seen them in other things. I don't think I've shown the commands for them yet. Alarm commands, here we go. So we'll look at the deregistration command first. Very simple, much like every other command. Stores a pointer to the alarmable, takes the alarmable in its constructor, executes. Yeah, very, very, very similar. These are going to be the exact same files. .cpp for the registration, .h for the deregistration. Yeah. I think I'm going to end the video here. Check the checklist, make sure I've done everything, and if I have, then oh, you know what? No, I know the one thing I haven't done yet. So this is window.cpp. This is really just an extension of the game class, but I just set all these functions in here to kind of, because they're not really part of the game, they're part of the system. So what we want to do is get them away from the engine and kind of compartmentalize them, because they're for the window. They're not for the game, for the actual running of the game. So that's why I didn't include these methods in the game. However, they're accessors. These are the accessors that we saw at the very beginning in the base game file. Oh, I know what the next video will be. It's going to be the documentation on the demo. So I think I've covered just about everything in the actual engine. So I'm going to cut this off now and go to the demo.